Alright, so today we're going to continue our exploration of linear relations. Alright, so remember from previous videos that linear just meant line. Alright, and so here we have a question, here we have an example question, and it says a pizza has a base cost of $15. Okay, so our pizza has a base cost of $15. It then costs $1.50 per extra topping. So we're showing a relation as a table of values, as a Cartesian plane, and as with a line of best fit, and as an equation. Okay, so the first thing that we'll do is our table of values. Okay, so what is the relation? Well, the relation is basically a relation between the number of toppings and the cost of a pizza. Alright, so that's what the relationship is. We're comparing how much the cost, or what is the cost of a pizza for the amount of toppings that it has. So those are our two variables. Our two variables are going to be cost and the number of toppings. Okay, so when we set this up in our table of values, we're going to have this set up. And remember from previous videos that, just remember that this value, the first one that goes here, is the independent variable. And the value that goes here is the dependent variable. And remember, the dependent variable is the one that depends on the independent variable. So what's changing here? The dependent is the changing one, or the responding, basically. Okay, so what's changing here? Well, what is changing is the cost. So the cost of the pizza is changing in dollars. Okay, and basically that's changing, or that's responding to the number of toppings that are on the pizza. Okay, so number of toppings. Okay, so if I have 0 toppings, my pizza, well, has a base cost of $15, so it's going to be $15. If I have 1 topping, well, my pizza then costs $1.50 for that topping, plus the base cost is going to be $16.50. Okay, and then if I have 2 toppings, well, then we just add another $1.50 on there, because it's $1.50 for each additional topping, so it's going to be $18. And if I have 3, you can go on forever. You could do 4, 5, 6. I'm just going to do 3 here. So 3 is about $19.50. Oh, why don't I do 4 as well? So 4, we add $1.50 on there again, so it's $21. Okay, so that is how we would express a table of values, or sorry, express a relationship, or a linear relationship of number of toppings for the cost of a pizza in a table of values. Okay, so remember that table of values is one way to express a relation. The second way to express a relation, well, which we're asked for next, is a Cartesian plane. Okay, so that is what we have over here on the left hand side of our screen, or a graph, a Cartesian plane, anything will work here. So on the x-axis, remember that I told you along the x-axis you have to do the independent variable, independent, which is the number of toppings. Okay, and then on the y-axis you have the dependent variable, which here is going to be the cost. Okay, and make sure that you label your graph. Always label the axis, and always title your graph. Okay, so this is the cost of a pizza versus the number of toppings. Okay, so the next question tells us, it says do the Cartesian plane with a line of best fit. Okay, so the first point that we're going to have on our Cartesian plane is going to be the 0 and $15. Okay, and you could write this as an ordered pair, which would be 0, $15. Okay, so we find that on our graph here. I'll use a different color. So we have 0 and 15. So we find 0 on the number of toppings axis, and then we go up to find 15 on the cost axis, and we're going to find a point right there. The next point will be 1 and $16.50, or 16.5. So 1 is here on the x-axis for number of toppings, and 16.50. So I have to find this on here. So this is 15, that's 20. The way this graph's at 16, 17, 18, 19, and 20. Okay, so that's 16, 17, 18, 19, and 20. So 1650, we find 1, and 1650 will be right there. The next one is 2 and 18, so you find 2 and go up to 18 here. Next one is 3 and 1950, so 3 and 1950. Next one is 4 and 21, so we go to 4, and that's 20, 20.5, and 21 is right up here at the top. Okay, so there's our relationship as a Cartesian plane or a graph, okay, or a coordinate plane. Okay, so when you look at this here, we can see that it's a straight line increasing up, and that's what makes this question a linear relationship, because remember, linear meant line. It's a straight line. Okay, so on my graph, I need to still do my line of best fit, so I draw my line through all the points there, line of best fit. Now this should be a straight line here, so I'll see what I can do about making that a straight line. So you draw your line as straight as you can through there, and you know it's going to go on forever. You're not going to have an arrow going left, because that wouldn't make sense to have negative toppings. You can't ever get less toppings than 0. Okay, so then what you're going to do is answer the next question here. So it says, we need to do it as an equation. We need to show this relationship as an equation. Okay, so remember when you're doing the equation, so we'll do number 2, equation. So if we were doing this in English class, we would say, well, the cost is 15 plus the cost of additional toppings. Okay, and then what we're going to do is try to derive a mathematical equation for this. So cost, okay, we'll label that C, is equal to 15 plus the cost of the additional toppings. So 15 plus the cost of the additional toppings. So this will be the cost of the additional toppings, and so the additional cost will be, well, each topping is $1.50 per topping, so $1.50 multiplied by the number of toppings. So we're going to call our number of toppings n, so it's going to be $1.50 n, and that's going to be our equation there. So this whole thing is your equation, which represents that relationship between cost and the number of toppings. Okay, so that answers part A. Part B says use the graph to determine how much pizza it will cost for 6 toppings. Okay, so for 6 toppings, that's right here. So we use the graph here. So what you would do, I actually didn't put enough of my graph here, but what you would do is you would find 6 along the x-axis, so 4, 5, and then 6 would be somewhere over here where I didn't put that on the graph. You go all the way up to your graph, find the line, and then go over and find it on the y-axis there, and that would be the number of toppings. So each of these points corresponds to a cost, so you'd find the point with 6 toppings, go all the way up, and then answer whatever the y-axis said here. The next question says use the equation to determine how much a pizza will cost for 20 toppings. So for question number, or for number C, or letter C, so for C, I'll put C here. Well, we know that there's 20 toppings, so n is equal to 20, because remember, n stood for the number of toppings and C stood for the cost. You substitute that into the equation. So C is equal to 15 plus 1.50 times the number of toppings, which is n, but remember that you know n is 20, so you get C is equal to 15 plus 1.50 times 20. Alright, so that's 20 toppings there. And so all you got to do is solve this. You can use your calculator, or you should be able to do this one in your head. So $1.50 times 20. Well, $1.50 times 10 is 15, and then times 20 then would be 30. So it's 15 plus 30, so it would equal $45. And that would be the cost of your pizza. Alright, and so your pizza is $45. It's a pretty expensive pizza, but I bet you it would be delicious. Okay, determine the 20 toppings. Use the equation to determine how many toppings a pizza worth $30 has. Now we're given the different variable, or actually given the value of the pizza, and we're wondering the number of toppings. So this time it's a little bit different, so I'll put the answer here, D, but now we know C is equal to, if the cost of the pizza is $30, so C is equal to 30 this time, but we don't know N. N is unknown, so N is unknown, so you substitute that in there. So C is 30, so we sub it into the equation. So remember, the equation is C equals 15 plus 1.50 N. So C is 30 equals 15 plus 1.50 N. And remember how to solve linear equations. You have to get rid of the 15 here. So you subtract 15 from both sides. And so you end up with 15 equals 1.50 N. Then the next step would be to divide by 1.50 N. Divide by 1.50. And when you do that, you're going to get a value of N is equal to 10. So this would be a 10 topping pizza. Alright, so that's basically how you answer a question with linear relations.